Hi, I'm Matt, and in this video we're going to go over solutions, particularly what the three main types of solutions are and how a substance actually dissolves to create the solution. So first, what is a solution? A solution is a homogeneous mixture in which particles are dissolved in a liquid. So remember, homogeneous means uniform, so whatever dissolved is spread out equally throughout the solution. And these particles that we're dissolving are called the solute. And then the liquid we're dissolving the particles in is called the solvent. Now let's try doing an example where we identify the solute and the solvent. So our example here is NaCl aqueous, also known as table salt. NaCl is salt, and then that AQ in parentheses means aqueous, which means it's dissolved in water. So what would be the solute here? The solute would be NaCl because that's the substance that we're dissolving in the water. And what would the solvent be? That water we're dissolving the salt in is the solvent. Now that we know what the solute is, how does it actually dissolve into the solvent? We call this process dissolution. And this is when a substance breaks up into its constituent ions and enters the aqueous form, also known as it dissolves. So what that means, breaks into its constituent ions, is that solid NaCl, or solid salt, creates positive sodium ions and negative chlorine ions in the solution. It breaks apart into its two pieces. So how does this happen? What happens is the ions in the substance become more attracted to the liquid than they are to each other and get pulled apart. So the Na plus from the NaCl gets more attracted to the O minus in water, and the Cl minus gets more attracted to the H plus in water, and water is able to pull the two pieces apart, causing it to break up into its ions and dissolve. A way we like to say this is the solute-solute interactions, or the attraction for the Na plus and the Cl minus is weaker than the solute-solvent interactions, or the forces between the water and each ion. Here's a visual to help you understand that a little. So on top we just have NaCl with the Na plus ion and the Cl minus ion. Then below it you see I have the water molecules. The O minus is attracted to the Na plus, and the Cl minus is attracted to the H plus, and they get pulled in different directions. And if this attraction is strong enough, which with NaCl it is, the Na and the Cl eventually completely break apart and then become the ions. We call this breaking apart dissolution or dissolving. Next, we're going to talk about precipitation, which is the opposite of dissolution. This is when ions in the solution come together and form a solid that sinks to the bottom of the solution and is no longer dissolved. That solid is called the precipitate. So here, you see that the sodium ion and the chlorine ion attract together and then bond through ionic bonding and create NaCl, or salt, and it sinks to the bottom of the solution. There are three types of solutions that we're going to go over in this video. The first is an unsaturated solution, the second is a saturated solution, and then the third is a supersaturated solution. So firstly, let's talk about unsaturated solutions. In an unsaturated solution, all of the solute already in the solution is dissolved, and if we add more solute, it will continue to dissolve until the solution becomes saturated. And when we have an unsaturated solution, we say the rate of dissolution, or the rate that the solid goes into the solution, is greater than the rate of precipitation, or the rate that the solid's forming. This is why everything's able to dissolve due to the unequal rates. Next, let's talk about a saturated solution. The first thing to note is the saturation point. This is the maximum amount of solute that has been added or dissolved, so no more can be added to the solution. And if we do add some, it will just sink to the bottom. It won't dissolve unless we were to take some out of the solution, so it could. Saturated solutions are said to be at solution equilibrium. This means that the rate of dissolution is equal to the rate of precipitation. So as a solid particle on the bottom dissolves, one from the solution precipitates. This is why on the last set I said doesn't immediately dissolve, because it eventually might, but only with the trade-off of something else precipitating. Due to this, the total amount of solid on the bottom and the amount dissolved, they won't change. They will stay constant. The last type of solution that we are going to discuss is a supersaturated solution. This is when the solution has more solute dissolved than the theoretical max. This is because it takes energy for precipitation to occur. So if there's not enough energy for the solute to precipitate, the solution can go above that theoretical max or can go above its saturation point. But this is very unstable because if even the tiniest bit of energy is added, all of that excess solute will precipitate now that the activation energy has been met. At that point where everything's coming out of the solution, we say that the rate of precipitation is greater than the rate of dissolution. Now, here are 5 practice questions that you could try on your own. The first one tests if you know the difference between the solute and the solvent. And then 2 through 5 is testing your knowledge of the 3 different types of solutions. At this time, I encourage you to pause the video and try these questions on your own, and the answers will be provided for you on the next slide. The solutions are as follows. In question 1, KBr or potassium bromide is the solute, and H2O would be the solvent. For question 2, saturated solutions are said to be at equilibrium. For question 3, a solution with more stuff dissolved than the theoretical max is called supersaturated. For question 4, if everything dissolved, we know that this solution is unsaturated, and the point at which the stuff will stop dissolving is known as the saturation point. And lastly, in a saturated solution, the rate of dissolution equals the rate of precipitation. Hopefully you got these. If not, feel free to leave any questions you have in the comments below and I will respond to you as quickly as possible. Thank you so much for watching. Have a great day.